all the rectangles are going to have the same base length. Okay? So new quantity delta x. Delta x is the base length, you might say, or width, they're going to refer to it, base length of the approximating rectangles. All right. Now there's a formula for it. The formula is delta x equals b minus a on n, okay? Where AB is the interval that we're talking about, mine's 0 to 2, and we already know what n is. Okay? N was the number of rectangles. So in this case, for the problem I'm doing at the moment, the picture I've constructed here, and the choice of number of rectangles, my delta x calculation in this problem, delta x is 2 minus 0 on 4, which is 1/2. Okay, so each of my rectangles will be exactly 1/2 length for its base. Okay. Now I had an idea of what I was going to do with this problem ahead of time, so I already have spaced this appropriately for me, right? I have a half here, another half, another half. I have 4 halves here. Those four half units would add up to 2, of course, and that covers the whole distance over the entire interval of concern, which is 0 to 2. So each of these spaces here, we're going to construct a rectangle where this bottom part here, let's take this one for example, right? There's delta x, and here's another delta x, and so forth, right? For each one of these, right? There's the delta x base length. We're gonna raise, in a sense, a rectangle above this base length, and then we're going to have 4 of them, and we'll just add them together, and that will be it's a very crude approximation, a crude way to approximate things with rectangles. There are more sophisticated ways, but for a start, this is what we're going to do. All right, so now I have to choose one more thing. I've got my base lengths, they're all equal. That's another thing. In these problems, we always have equal base lengths, so that's equal to this one, equal to this one, which is equal to the last one, and so forth. It doesn't have to be that way, but for our very simple problems here, it should always be that way. All right, so now what we're going to have is we've got a base length. We know it's going to be 1/2, and we're going to have 4 rectangles across here. We should figure out how high each rectangle is going to be. Okay? So that's where the function values actually come into play. All right, you notice we haven't used the function at all yet. The function values. So f of x, the function values, and we're going to make a choice here. We're going to choose a sample point. Sample points determine height of rectangles. We've already got the base taken care of. We just need the heights, and then we just add them all together, add the areas together. All right, so what's the sample point business? The sample point is for each of these 4 base lengths in here, right? Each of these 4 subintervals, I'm going to pick a location within there, right? Let's just pretend for a moment, from 0 to 0.5, this rectangle I'm going to construct here. I'm going to pick this locale right here. It will map up to the curve, and then I would draw a rectangle, right, with that height. I'm going to draw one very quickly here. I'm going to erase it in a moment. All right, I would use that height right there, right? And that would be one rectangle right there. Okay, well, we can kind of see it. A rather thin rectangle in here, but I would use that as my first rectangle. Right, I would pick that point right there, perhaps. Okay, doesn't matter where you pick, in some sense. Okay, we'll have specific directions in a moment, but I'm just saying a sample point means a sample from anywhere within this closed interval from 0 to 0.5. Okay, and I could use this rectangle right here, whose height was the function height right here, mapped up to from this sample point I chose here. Okay? Now, in general, we don't just choose random samplings within the intervals to determine the height of the rectangle. Right? But wherever I would choose it, again, if I was in this interval and I chose right here, right, it would map up to the curve up here, and I would use that as the height, right, of my rectangle whose base was from 1.5 to 2. Okay, I hope that's somewhat clear. Nevertheless, what usually happens is you don't just take random samplings from within your rectangular bases. What you do is, with these beginning problems, you will take a consistent sampling from each subinterval here. And usually, perhaps all the problems in this textbook will either be, you're going to choose the left endpoint of the subinterval, or you'll choose the right endpoint of the subinterval and nothing in between. Okay? And that's really just for ease of computation for the most part. Okay? So I'm going to pick right endpoints for a moment. Okay? So that's my choice again. Right? There are a couple things here that are my choice. The problem will specify this in the textbook. Okay? So I'm going to choose, again, that's just me choosing for the sake of having an example here. I'm choosing right endpoints. Of subintervals. The book might be left endpoints. I'll do a left endpoint problem here shortly. Okay. Choose right endpoints of subintervals.